All right, time to wrap up Unit 1 and do some review and take a test to show off all you know here. All right, so let's look at some problems here. One thing we talked about here was angles. So here we got an angle BAD, an angle AC, ray AC. That's an angle bisector. So we want to draw a diagram first here. So we've got B, A, D. Remember the middle letter in a angle is the vertex. And then we've got AC. That is the angle bisector there. All right. Now we know that BAD is 84 degrees. That's given to us here. And we know that CAB is 2x plus 20. All right. Now we know this is an angle bisector, so I'm going to mark these as congruent. And CAB, that's this guy right here, is 2x plus 20. Well, since this is an angle bisector, we know that that's half of it. So you can do this a couple ways. We can say that, well, half of 84 is 42. So we could say 2x plus 20 equals 42. Or we could say 84, the total degrees, is 2 times that expression, 2x plus 20. All right? So 2 ways to go. You'll get the same answer either way. Let's try this guy here. Subtract 20. 2x equals 22. Divide by 2. And x is 11. All right? You get the same thing if you solve this guy. 84 equals distribute. All right? And then subtract 40. And then divide by 4, and we get the same answer. Great. Now, we want to find the measure of CAD. That's our ultimate goal. So CAD, well, that's just the other angle here, right? So CAD, that wasn't given to us, but we know that that's an angle bisector, so these two are the same. So we can plug in 11 to that expression, 2x plus 20. And so 2 times 11 plus 20 gives us 22 plus 20, which is 42. Well, we could have kind of gotten that from the original, right? So measure of angle CAD is just going to be 42 degrees. So I guess we didn't need to plug that in. It's just half of 84. All right. Well, moving on. Number 2 here, we got point M as the midpoint of LN. So we're going to want to draw a diagram of this. So we've got a line. I get a little line for us here. There's a line. And this is L, and it's a line segment. Remember, when there's no bars on it, that means line segment. So L, N. All right? And then we've got a midpoint here, M. Okay? So this is a midpoint. I'm going to put these marks showing that that's exactly in the middle. All right, so now we know that the whole thing is 10x, and we know MN is 4x plus 10. So 2 times the MN, 4x plus 10, because MN is just half of it. So we have to double that to get the whole. So the 2 parts add up to the whole is the key there. All right, so this is only half, so we've got to double this to get this, and we got to build our equation that way. Now it's all algebra. So distribute 8x plus 20. Let's subtract the 8x from both sides, and 20 equals 2x. And if we divide that by 2, we get x equals 10. By the way, x is not always a whole number, so don't expect it to be so, all right? Ln is... I'll just fix that. What just happened there? Okay. So Ln is 10x. So we can take what we found there, the 10, and let's plug that in. So Ln. Now, by the way, notice there's no bar over this. That means the length of Ln. This means the length of Mn. Don't forget that. So Ln is 10 times x, which is 10 times, well, we just found out that x is 10, which is 100. And there's the length of LN. Okay? Great. Well, now let's move on to some midpoints. We learned that the midpoint was the average, all right? So if we have 2 points, and we could graph them and just kind of use slope to get this. That's one way to go. But we want to find 2 things. We want to find PQ. Now that doesn't mean say PQ. There it is. Notice there's no bar. That means the length of PQ. Okay. So we want to find the length of PQ and the coordinates of the midpoint, all right? So 2 parts. Length. We could graph this and use the Pythagorean theorem. That would be fine. So you could sketch it out and say 3, negative 12 is somewhere down here. There's like Q. And then negative 715, well, that's going to kind of be way over here, negative 715 for P. And you could think about, so there's our line, not a very straight line, but then we could think about the rise and the run, and you can count that out, and you could use the Pythagorean theorem. Okay? Totally fine way to go, all right? But it's going to take a little bit of thought there, but let's try the distance formula. I'm going to go with the distance formula here. Distance formula is really just the Pythagorean theorem because we've got x2 minus x1 squared, which is like the a squared. y2 minus y1 squared, that's like the b squared. And so let's plug these in. All right, let's take our x's, which is 3 and negative 7. Watch out for those negatives. We've got the y's, which is negative 12 minus 15. Real careful again with your minus and your negatives. And so this becomes, well, 3 minus negative 7, that's like plus, so that's going to be 10 squared, which is going to be, we can figure that out in a second. This is going to be negative 27 squared. Oh, boy. That's one I don't know off the top of my head. So now we can keep going. So that's going to be the square root of 100 plus, and this comes out to be 729 is the square root of 20 or 27 squared. So this is the square root of 829. All right. I don't think that's a perfect square. If we plug it in, it's about 28.79. All right, so there's the length of the line segment. Now if we want to find the midpoint is the average of the coordinates. So we're going to take those 2 coordinates and we're going to average them. Okay, so to find the x-coordinate of the midpoint, we're going to average negative 7 plus 3 divided by 2. That's negative 4 divided by 2, which is negative 2. The y-coordinate is 15 plus negative 12 divided by 2, which is going to be 3 divided by 2, which is 3/2. Leave it alone. Fractions are great. So there's our coordinates of the midpoint, and so we get our midpoint at negative 2 3/2. If you really want to make that 1.5, you can, but you want to stay away from those decimals if possible. All right, so there's that. Distance and midpoint. So now if we have a different situation, we got a midpoint of RS is at 4, 2. Now a little picture might be helpful here. So we have RS as a line segment. And we know at 4, 2 is the midpoint. And that's a funny point. Then one of the endpoints is at 7, negative 12. So 7, negative 12, well, that's somewhere down here. Okay, probably farther down, but this is just a model. So 4, 7, negative 12. And so there's an S that we're looking for somewhere up here. So this is a line segment. That's the midpoint. We'll go the same distance up here, and there's S. Okay, my drawing is not to scale because I ran out of room down here. So, but that's the idea. I want to find that. Well, we can use some patterns, and if you look carefully at the patterns, you can kind of figure out this guy's going from 7 to 4. That's going down 3, so we're going to go down 3, so on and so forth. The very important thing is that we call S x comma y. Okay, so that's really important there. Okay, so call it x comma y. And then the best way to do this when you have big numbers like this is to just make the average. We know that this 4 is the average of these two numbers. 4 is the average. Now, how do we find an average? We average by adding and dividing by 2. So these two added and divided by 2, x plus 7 divided by 2 has to equal 4, right? That's the midpoint formula. So here's a simple equation, and we can solve it. Times 2 on both sides, and we're going to get 8 equals x plus 7. Subtract 7, that's easy. X is 1. So there's our x coordinate. Now what do we know about the y coordinates? So this 2 is the average of y at negative 12. So we know that 2 is the average of our mystery y value and negative 12. Average means add and divide by 2. And we can solve that pretty quickly. Double, double. Okay, 4 equals y minus 12. Add 12 to both sides, and we get y equals 16. Okay, so the final answer is our coordinates is that S is at 1, 16. That's the answer right there. Okay? The midpoint is the average. That's the key. Remember, the midpoint is the average of the coordinates. So now we've got some block buildings. Let's do some patterns here, kind of like we did in green face cubes. All right, we've got 3 block buildings. How many squares will be in the next 3 figures is the question, all right? So, okay, we see that the block building is growing. We have 1 here, we have 4, we have 2, 4, 6, 7 there, all right? So we can kind of see that the pattern is going up by 3 every time. So the next 3 will be 10, 13, and 16. Now, the pattern is going up by 3. You can do this a couple ways. Since the pattern is going up by 3, this is a linear pattern. And so linear patterns, the slope, the rate of change is 3. So since we're going up by 3 every time, that's an indicator right there that so on and so forth, going up by 3. So that tells us our formula is going to be 3 times n plus or minus something. Okay, and if we test this out, 3 times 1 is 3, but we want 1. So we're going to have to subtract 1. Subtract 2, actually, right? 3 times 2 is 6. Subtract 2 to get 4. 3 times 3 is 9. Subtract 2 to get 7. All right? So it's going to turn out to be 3n minus 2. Now, another way to see this would be, we might look at this and say, you know what? I see like a center piece on each of these. And here we've got these legs around the side. This is a leg of 1. There's 3 legs, and there's 1 apiece. Here there's 3 legs, and there's 2 apiece. Next one's going to have 3 legs, and it's 3 apiece. Notice that these little legs, let's call them legs, is 1 less than the building number. So we could say another way to do this would be to say I have the 1 centerpiece plus we have 3 legs, and how many are in each leg? n minus 1. And that formula would be equivalent. All right? So two ways to do the same kind of thing there. Okay, cruising along. Collinear points. So collinear points have the same slope. So if we use these 2 points here, we're going to get a slope of 6 minus 12 over 4 minus negative 6. And that's going to be negative 6 over 10, which is negative 3/5. Okay, so the slope is negative 3/5. Now, if we look at these other 2 points here, we know the slope. Let's find the slope there. We have 6 minus negative 12 all over 4 minus x. So that has to be negative 3/5. And that's the key. So these slopes have to be the same. Well, let's clean this up a little bit here. So this is 6 plus 18, which is, we can do that, I think. 6 plus 18 is, 6 plus 12 is 18. What am I thinking? All over 4 minus x. This is now a proportion. And so we can cross multiply this. Okay, so let's cross multiply. We learned that in algebra. We have 5 times 18, that's 50, and 40, that's 90. And then we've got 3 times 4 minus x, that's negative 12, plus 3x. Add 12 to both sides, and we get 102. And then divide by 3. And 3 goes into 99 33 times. And so this would be, what, 34. So x is 34. X is 34. Okay, there you have it. All right, let's cruise on to the next page. Now we're going to name some geometric figures. Work with some vocabulary here. We want to know if these are true or false and give a reason for it. So is AR and B collinear? Well, here's A, there's R, and there's B. So no, that is false because they are not on the same line. Collinear means on the same line. So false. They are not on the same line. Next one. BW and AT are lines. So BW, and let's see if there's actually in the drawing. BW is right here, and AT are lines. Lines go on forever in 2 directions. So these are true. They're shown in the drawing, and they extend infinitely. Kind of a tough one to explain why, but something like that. BR and RT are opposite rays, so opposite rays have to have the same endpoint and go the same way. BR starts here, and let's highlight this guy. BR starts here and goes through R. RT starts at R and goes to T. So these rays do touch, but they're not opposite because they're not going in separate directions, all right? So no, and they don't have the same endpoint, so that's kind of the main thing. So once you know they have different endpoints, there's no way they can be opposite rays. Plane D can also be called plane ART. Now this one's a tricky one. D is the name of this plane. Notice there's no point next to D. And then plane ART. Well, AR and T are on the same line. And there's actually lots of planes that go through ART. We could draw more planes, maybe kind of like I don't know, there's maybe like a vertical one that goes through ART. That's not drawn in there. We could draw lots of ones at angles, things like that. So since ART are collinear, this has to be false. We can name planes with 3 letters. but you can't use 3 points that are collinear. So A, R, and T are collinear. So, sorry, kind of a trick question there, I guess. Okay. Here in a different drawing, name 2 opposite rays. So now with that idea, we got to find 2 opposite rays. And there's several ways to do this. We've got CB. So CB is a ray, starts at C and goes through B. And opposite of CB is CE. So those are opposite rays. That would be a C. And then we could also come down here and talk about like DA. DA is right there. And DE. It's another combination. And in fact, those are the only possible combinations. So, or DA. Let's find a better way to do that. So there's 2 possible opposite rays. And again, opposite rays have the same endpoint. Intersection. Intersection is where 2 things cross. So line M and line N both intersect down here, kind of a mess because of all my drawings, and that would be at E. So they both intersect at point E. All right, E or point E. All right, remember, points are capital letters. All right, now we're going to draw a triangle here and work with it. So we got some points to plot. And we want to find the area. So let's plot it. Gotta watch out here. The axes are going by 2. So we've got A at -4, 4. Nope, that's -4, -4. Gotta read carefully. So -4, -4. B at 4, -4. There's B. And C at 2, 6. And let's draw in our triangle. So here's our triangle. We need to find the area exactly. And so we got to remember our area formula from middle school. 1/2 base times height. So that's the area of a triangle. So we need to know the height. Well, it turns out that that's pretty easy to count because of the way the triangle's made. And so we have a height of, count by 2s, 10. And a width of 10. Sorry, width of 8, actually. Next question wants the exact length. Well, one of them is 8. That can be counted. And then we can use the Pythagorean theorem or the distance formula for the next couple. I think I'll use the Pythagorean theorem here. So we're going to go up 10. And careful, we're counting by 2s here. And over 6. All right, so we've got 10 squared plus 6 squared equals c squared. And this is going to be 136 when we square and add. And we're going to square root. And so we get the square root of 136. That's not a perfect square, so we're just going to leave it alone. Then over here, we're going over 2 and down 10. And so that leaves us with 2 squared plus 10 squared equals c squared. And it's going to be 104. And when we square root, we just get the square root of 104. All right. So, square root of 104. Whoa, come back. All right, so now the question is, classify the triangle. So we got to figure out which one of these is largest. And so 8 squared is 64. So this is going to be larger. If you want to plug it into a calculator, you can see that. So that's our c squared. And this is and the other two will be our a and our b. So c squared. We're going to find out if that is equal to, less than, or greater than 8 squared plus the square root of 104 squared. So when you square a square root, it just cancels out the radical, right? So we have 64 plus 104. So that ends up with 168 on the right, so that's greater. So the c squared is less than, and when the c squared is less than the a squared plus b squared, this is an acute triangle. Okay? So we've proven that yes, it is an acute triangle. All right, a couple more here looking at some angles. We want to measure AOB. So AOB, looking at the protractor, that's this guy right here, AOB. AOB. Okay? And there we go. So that guy has an angle of, is it 150? No, that's an acute angle. So that must be 30 degrees. Okay? So we got angle AOB is 30 degrees. Then we got BOD. So if we take a look over here at BOD, so now this one's a little different. BOD is not lined up on the 0 line. So we've got to see that D is at 142. Using the inside numbers there. And D is at 30 degrees. And so if we subtract those, we get 140 minus 32. We can find the difference. So we have 140 minus 32, and that equals 108 degrees. Okay? And then we've got EOB. Next, EOB. And that is right here, EOB. So we just got to make sure we use the right numbers. 0 is on the outside, so we're using outside numbers, and so it's going to be 150. All right, let's try that again. 150. Okay, so the relationship between EOB and AOB, let's look at those. EOB is this guy here, right here, and then AOB. These are a linear pair. All right, so linear pair form a straight line, and they're very useful. All right, one more. So we've got a situation where ABC is 110. ABD is part of that, 2x minus 5. And the angle D, or 5x plus 15 is DBC. Well, let's draw a picture. We got a 110 degree angle by ABC. All right, 110. And this is AB. We'll see, because we just drew it. Okay. Now, ABD is 2x minus 5. Well, where's D? It's somewhere out here. 20x minus 5. And DBC is 5x. So DBC is 5x plus 50. Okay? So we know the parts add up to the whole. That's the key. The whole thing is 110. So we know that the 20x minus 5 plus the 5x plus 15 has to equal that grand total, which was 110. So we have 25x, and I think these guys just cancel each other out, huh? Wait a minute, didn't copy something down. There we go, it's 15. So we add 15 and negative 5, we get 10. Okay, so if we subtract 10, then 100 equals 20x, 25x actually, equals 110 divided by 25, and we end up with x equals 4. So there you have it. Should be ready for the test now. And that covers all the important things there. So study hard and good luck.